Hey everyone, and welcome back. Ready for another deep dive?
Always.
Awesome. Today we're tackling a topic that's, well, it's literally life or death, but something most of us probably don't think about too much day to day.
Definitely essential, though.
Absolutely. We're talking blood transfusions. I've got a really interesting mix of sources for this one. Medical journals. We've got some blood bank, procedure manuals.
Even some lecture notes in the mix.
Yeah, lecture notes, the whole shebang. So should be a fascinating deep dive.
For sure. It's where the science really gets really, really fast, talking about those procedures that make these everyday medical miracles possible.
Okay, so before we get too deep into the weeds here, can you set the stage for us? Like, why should we care so much about transfusions? Why is this such a big deal?
Well, I mean, imagine, a serious accident, right? Major surgery or really anything with significant blood loss.
Right.
A transfusion can be the difference between, recovering and, well, not recovering.
Yeah, it's not like you're thinking about that on your average Tuesday afternoon.
No, not at all. And it's more than just replacing the volume, right? I mean, blood carries oxygen, nutrients, fights infection. It's essential.
Right.
But here's the thing. Not all blood is compatible, and that's where things get really interesting.
Right, and that's where this whole world of pre-transfusion testing comes in. Right, I was looking at this article by Daniels from 2002, and honestly, like the sheer number of blood group antibodies it's kind of mind-blowing.
Oh, yeah. Yeah, it's a complex system, but we have two main goals, right? One, making absolutely sure that donor blood is compatible with your blood.
Right.
And then two, screening your blood for any antibodies that might react with the donor's blood, even if the basic types match.
Right. So it's kind of a double check system to avoid any surprises, basically.
Exactly. And understanding the why behind the tests is really crucial. And those lecture notes from Joe Chaffin, those are great for this. He explains antigens and antibodies really, really well.
Yeah, I thought those notes were super helpful. But could you give us the kind of the quick and dirty version of antigens and antibodies again?
Sure. Think of antigens, right? Like little ID tags on red blood cells.
Okay.
Antibodies produced by your immune system, kind of patrol for anything that doesn't belong.
Right.
If an antibody finds a foreign antigen, boom, immune response. And that can range from, minor inflammation to a serious, even life-threatening reaction.
Wow. So wrong blood, wrong antigens, and your body basically attacks the transfusion.
That's the gist of it, yeah. Chapin's notes get into agglutination, too. That's where the red blood cells actually clump together. Big warning sign of incompatibility.
Interesting, yeah. He also mentioned something called zeta potential. What is that all about?
Yeah, so that's the natural negative charge on red blood cells.
Okay.
Thanks to a molecule called sialic acid. And this usually keeps them from clumping together, but for testing, we sometimes need to force them closer together,
Oh, okay.
using special techniques and reagents to see if those hidden antibodies are lurking.
So it's like setting a trap to see if any incompatibility kind of reveals itself.
Exactly, yeah, precisely. And that brings us to the kind of the detective work of antibody identification.
Yeah, and I really liked that manual from Boston Children's Hospital on that. They use these panel cells and reagent testing to eliminate suspects, until they find the specific antibody a patient might have.
Very systematic, very much like solving a puzzle, right?
Right.
So you start with red blood cells with known antigens, mix them with the patient's serum, and see which ones react. It's like a blood bank version of Clue.
And I bet the stakes are a little bit higher than in a board game, right?
Oh, absolutely, yeah. Identifying the correct antibody is critical to getting patients the right blood. Mistakes can have, really, really serious consequences.
Which is why those strict protocols in the ZBCH Children's BB30 compatibility testing and the ZBWH B0-1 main lab policies documents are so important.
Yeah, they highlight, that need for meticulous procedures. Remember the wrong blood in tube statistic Chaffin mentioned?
Yeah.
1 in 2,000 chance of getting the wrong blood in the tube. Kind of a scary thought.
Yeah, that's kidding. Those manuals don't mess around. Even a typo on a label. Start over. No exceptions.
It's all about patient safety, Blood bank professionals are kind of the unsung heroes in all this. They're the ones ensuring accuracy at every step.
Yeah. And speaking of specific needs, the ZBWHB0-1 main lab policies document also talks about newborn transfusions. What makes them so different?
Well, newborns have, immature immune systems, makes them incredibly vulnerable. So they need extra safeguards, right? Like irradiated blood to prevent a really nasty complication called transfusion-associated graft versus host disease.
Wow.
And they need blood that's free of certain parasites like babesia, which can be really dangerous for them.
Okay. There's also a section on interpreting mixed field reactions in cord blood. What's going on there?
Right. So sometimes cord blood has a mix of the baby's red blood cells and some of the mother's.
Okay.
And this can make it a little tricky when you're trying to figure out the baby's true blood type. But thankfully, there's a table in the document that helps blood bankers decipher those results.
Sounds like a lot of expertise goes into every step of this process.
Oh, absolutely. Yeah. Blood bank professionals are highly trained specialists. They play, a critical role in ensuring patient safety, really the backbone of transfusion medicine.
Okay, so we've covered why compatibility is so key, how complex this pre-transfusion testing is, and the meticulous procedures that ensure safety. But what about the future of this field? Are there any exciting advancements on the horizon?
Yeah, there are some really exciting things happening. Remember my 2012 article by Zhang we talked about?
Yeah.
It really highlights the potential of molecular methods, particularly genotyping, to change how we approach transfusions.
Genotyping, that sounds pretty high tech. How does that work?
So instead of relying solely on those traditional serological tests, the ones where you're mixing blood samples and observing reactions,
Right.
genotyping allows us to look directly at the genes that code for red blood cell antigens.
Oh, wow.
So it's a more precise and efficient way of identifying blood types and predicting compatibility, especially for patients who need multiple transfusions over time.
So it's like reading the DNA blueprint to figure out a person's blood type and match them with donors more accurately.
Exactly. And it's incredibly valuable for patients with chronic conditions like sickle cell disease or thalassemia who often need transfusions regularly.
Right, that makes sense. I mean, the more transfusions someone receives, the higher the chances they could develop antibodies against donor blood, right?
Right.
So genotyping seems like a real game changer for those folks.
Yeah, it really could be. It's like personalized medicine.
Wow.
But for blood transfusions, making sure each patient gets the best possible match and minimize the risk of reactions.
Yeah, that's amazing. Are there any other advancements in antibody identification or antigen typing that you're excited about?
Oh, definitely. There's been a lot of progress in developing automated platforms that can perform these tests much more quickly and efficiently.
Okay.
And this not only speeds up the process, but it also helps reduce human error, which is, always a concern in a laboratory setting.
Yeah, I can imagine that automation would be a huge help, especially in busy blood banks that are processing tons of samples every day.
Oh, absolutely. And it frees up blood bank professionals to focus on more complex cases and personalized patient care. It's a really dynamic time to be working in this field.
Yeah, it's really amazing how far transfusion medicine has come. It's a real testament to the dedication and hard work of all the scientists and medical professionals who've made these advancements possible.
Yeah, I agree. And it's important to remember that even though blood transfusions are often taken for granted, they really represent a remarkable achievement in modern medicine.
They really do. Okay, so we've covered a lot of ground here, why transfusions matter, the ins and outs of pre-transfusion testing and those meticulous procedures that ensure safety. We've even peeked into the future of the field with some really exciting advancements. But let's take a moment to recap the key takeaway here.
Sure. I mean, it all starts with understanding why blood transfusions are so crucial, right? I mean, they're literally life-saving interventions for countless people.
Absolutely.
And then, we dug into the complexities of pre-transfusion testing, and it goes way beyond just matching basic blood types.
Right.
It's a whole detective process of identifying and screening for tons of antigens and antibodies.
Right.
To ensure compatibility, minimize the risk of potentially fatal reactions.
Yeah. And we explored how antibody identification actually works, right? It's like a scientific puzzle with really high stakes,
Yeah.
highly trained professionals using these sophisticated techniques and strict protocols to pinpoint exactly what antibodies a patient might have.
Right, exactly.
And we even discussed the future of transfusion medicine, looking at, incredible advancements like genotyping and automation, which are, I mean, they're really revolutionizing the field and continually improving patient safety.
Absolutely. It's remarkable how this entire process from donation to transfusion really relies on a complex web of scientific knowledge, technology, and human expertise.
I mean, it's a beautiful example of how, different parts of the healthcare system come together to save lives. We depend on the generosity of blood donors, the dedication and skill of blood bank professionals, and the expertise of healthcare providers to make these life-saving interventions possible.
It's truly a team effort.
Yeah, this deep dive has definitely given me a newfound appreciation for the intricate world of blood transfusions. It's not just about replacing lost blood, it's about a whole symphony of biological processes and meticulous procedures all working together to keep people healthy.
It really is. And it all starts with that simple but profound act of donating blood.
Right.
I mean, every donation has the potential to save a life. So if you're able to donate, please consider doing so.
Well said. This deep dive has given us a lot to think about. What stands out to you as the most important takeaway from all this? Yeah, for me, it's just how much is going on behind the scenes,
Yeah.
With transfusions. It's easy to just think of it as like, oh, it's a bag of blood.
Yeah.
But it's so much more than that.
It really is. It's not seeing a finished car and forgetting about all the engineering and manufacturing that went into it. There's
Right.
a whole chain of events, like tons of knowledge and precision that go into every single transfusion.
And we're just so lucky to have, dedicated people making it all happen,
Yeah.
from those who donate blood to the lab technicians who analyze and prepare it, to the doctors and nurses who administer it. It's really it's a real testament to human collaboration and scientific ingenuity.
Absolutely. It really makes me appreciate that interconnectedness of our healthcare system,
Yeah.
and the individuals who keep it running so smoothly.
Speaking of the future, do any of these sources kind of hint at what might be on the horizon for transfusion medicine? Are there any breakthroughs or challenges we should be aware of?
Well, that Chang article we talked about from 2012 really pointed to the potential of molecular testing, specifically genotyping, to revolutionize how we approach transfusions.
So instead of those traditional serological tests, where you're mixing blood and looking for those reactions,
Right.
genotyping actually looks at the DNA itself.
Exactly. It's like going straight to the source code, right? Determining someone's blood type and predicting compatibility with incredible accuracy. And this is especially crucial for patients who require multiple transfusions, like those with chronic conditions, because they're more likely to develop antibodies against donor blood over time.
Like those with sickle cell disease or thalassemia that you mentioned earlier?
Exactly.
Genotyping could really help tailor those transfusions, more precisely and kind of minimize those risks, right?
Precisely. It's all about improving long-term outcomes for these patients. It's fascinating to think that we could be moving towards truly personalized blood transfusions,
Yeah.
based on individual genetics.
That's incredible. And are there any other advancements in antibody identification or antigen typing that you're particularly excited about?
Oh, definitely. The development of automated platforms is a real game changer. These
Right.
platforms can perform tests much faster, much more efficiently.
Right.
And this not only speeds up the process, but also helps reduce human error,
Right.
which is always a concern in a laboratory setting.
Especially in busy blood banks that are handling so many samples every day.
Absolutely. And it allows, those highly skilled professionals to really focus their expertise where it's most needed.
Right.
On those complex cases, ensuring, personalized care for each patient.
This deep dive has been a real eye-opener, showing just how complex and how promising the world of blood transfusions really is.
It really is. And it all starts with the generosity of blood donors. If you haven't considered donating before, maybe learning more about the impact has sparked an interest.
It truly is giving the gift of life.
Couldn't have said it better myself.
So as we wrap up this deep dive into the world of blood transfusions, what's one final thought-provoking question you'd like to leave our listeners with?
Well, we've explored the science, the processes. We even glimpsed the future of blood transfusions.
Right.
But as we move forward, I think it's crucial to remember that human element. Every blood transfusion represents a connection between individuals.
Yeah.
A donor who selflessly gives a part of themselves, and a recipient whose life is saved or improved by that gift. As we continue to advance this life-saving procedure, it's vital to ask ourselves, how can we ensure that every aspect of this process, from donation to transfusion, reflects the very best of humanity?
Right.
Our compassion, our ingenuity, and our unwavering commitment to preserving life.
That's a really powerful question and a perfect note to end on. It reminds us that, even with all the science and technology involved, at its heart, this field is really about people helping people. So thank you for guiding us through this intricate and vital world.
It was my pleasure. Always happy to share the wonders of transfusion medicine.
And to our listeners, we hope this deep dive has sparked your curiosity and given you a deeper appreciation for the life-saving power of blood transfusions. Until next time, keep exploring.